Welcome to Module 19 of the Revit for MEP training program. In this module, we're stepping into one of the most powerful and creative areas of Revit, family editing. Family creation is at the heart of BIM. It's what allows us to build bespoke components, tailor content to project needs, and extend Revit far beyond its out-of-the-box library. Whether you're creating a simple 2D symbol or a fully parametric 3D object, the Family Editor gives you the tools to define geometry, behavior, and metadata in a controlled, intelligent way. In this module, we'll explore the fundamental principles behind stable, reliable family creation. The example we use is intentionally simple, a basic fan coil unit, but the techniques you'll learn here apply to every family you'll ever build. These principles form the foundation for more advanced topics like nested families, shared parameters, type catalogues, and formula-driven geometry. The process: why family creation needs structure. Before you start building a family, it's essential to prepare. You need to understand where the component will be used, what variations it needs, which parameters matter, what level of detail is appropriate. It's easy to get carried away adding unnecessary complexity. If a manufacturer produces a component in only one size, there's no need to make it parametric. If a detail will never be seen in drawings, there's no need to model it. To help guide the process, we follow a structured, repeatable workflow, a set of 10 stages that ensure stability, clarity, and predictable behavior. Think of it like building a creature. You start with the skeleton, then add muscles, then organs, and finally the skin. If you try to add bones after the skin is finished, everything falls apart. Family creation works the same way. 2D or 3D, understanding representation. One of the most important concepts in family creation is the distinction between 2D symbolic line work and 3D geometry. In many cases, the 2D representation of an object is completely different from its 3D form. A perfect example is a light switch. In 3D, it's just a small rectangular extrusion, but in 2D, it has a very specific symbolic representation used across the industry. This separation is intentional. 2D symbolic lines improve clarity in plan and elevation views, reduce the processing load on your computer, allow you to follow industry drafting standards, provide clean, readable drawings at any scale. 3D model lines, on the other hand, are used to simplify geometry without sacrificing accuracy. A grill, for example, doesn't need every slat modeled. A few model lines can represent it effectively. In this module, symbolic lines and model lines are introduced at the appropriate stage, reinforcing the idea that graphics and geometry serve different purposes. The 10 stages of trouble-free family creation. These 10 stages form the backbone of stable, predictable family creation. They apply to both standard families and in-place families, and they should always be followed in the same order. 1. Categorize. Every family must belong to the correct category. This affects visibility, scheduling, tagging, export behavior, how the element interacts with the model. Choosing the correct template, .rft, ensures the family behaves as expected. 2. Layout. Next, you define the skeleton of the family using reference planes. These planes form the framework that all geometry will attach to. Key principles. Use reference planes, not reference lines, unless you need rotation, mirror planes for symmetry. Avoid moving the template's original center planes. Use as few views as possible to avoid over-constraining the family. This stage is the bone structure of your component. 3. Apply rules. Rules are created using dimensions. Lock dimensions fix relationships. EQ toggles equalize spacing. Labeled dimensions become parameters. These rules control how the reference planes behave when the family flexes. 4. Test. Testing is essential. Change parameter values in the family types dialog and make sure the reference planes move correctly. If the skeleton doesn't flex properly now, the geometry will fail later. 5. Add 2D line work. Now you add symbolic lines to represent the object in plan or elevation. This is where you define the drafting appearance, often very different from the 3D form. Symbolic lines improve clarity, reduce processing load, follow industry standards, can be visibility controlled by detail level. 6. Test again. After adding 2D line work, flex the family again. Make sure the symbolic lines follow the reference planes correctly. 7. Add 3D geometry. Only now do you begin modeling the 3D form. Use extrusions, voids, model lines, sweeps, blends. Always lock geometry to reference planes, never to other geometry unless absolutely necessary. 8. Test again. Flex the family once more. Check that the 3D geometry moves correctly with the parameters. 9. Subcategorize. Subcategories allow you to control visibility, line weight, color, export layers. This is especially useful for complex families with multiple components. 10. Define metadata and types. Finally, you add the non-graphical information, the BIM data. This includes manufacturer, model number, performance data, classification codes, any parameters needed for schedules. You also create types, which are simply saved sets of parameter values. Non-graphical information, the BIM side of families. Family creation isn't just about geometry. BIM relies on the connection between graphics and data. Metadata may include make and model, acoustic or fire performance, serial numbers, electrical ratings, maintenance information, any specification data needed for schedules. Not all data belongs in Revit. If information is intended for non-Revit users like nurses, maintenance staff, or procurement teams, it may be better stored in an external database. The rule of thumb is simple. If the information appears on drawings or schedules, include it in the family. If it's for external systems, link it using a code or identifier. In this exercise, we're going to create a fully parametric family, a simple fan coil unit using the 10-stage workflow described earlier. We'll begin with reference planes, apply rules, add 2D symbolic line work, then build the 3D geometry, and finally test and refine the family. Let's begin. Step 1. Categorize. Start by opening Revit. From the application menu, choose Family. A dialog appears listing all available family templates. Scroll through the list and select metric mechanical equipment.rft. This template automatically assigns the correct category for our FCU. Click Open to begin the family. Step 2. Layout. Make sure the reference level floor plan is the active view. Maximize the view so you have plenty of workspace. Now we'll define the major features of the FCU using reference planes. Draw reference planes to outline the main rectangular body of the unit, as shown in the exercise diagram. The red lines in the document represent the original template crosshairs. These will appear green on your screen. Remember, use reference planes, not reference lines. Mirror planes for symmetry. Keep the original center planes untouched. Use as few views as possible to avoid over-constraining the family. These planes form the skeleton of the family. Step 3, apply rules. Next, we'll apply dimensional rules to control the reference planes. Select the Align Dimension tool and place dimensions horizontally and vertically to locate the insertion point at the center of the main rectangle. The outermost dimension controls the overall size. The EQ toggled to keep the center planes equal on both sides. Continue adding dimensions to position the ducts, pipes, and electrical connections exactly as shown in the diagram. Now we'll convert key dimensions into parameters. Select the far left dimension on the ribbon, click Create Parameter in the Parameter Properties dialog. Name the parameter unit, _depth. Leave all other settings as default. Click OK. Repeat this process to create unit _width, duct _width, spigot _position. Next, lock the 3 dimensions marked with padlock symbols in the diagram. Switch to the left elevation. Reference planes shown, then lock the small 50 mm dimension. Label the left and right dimensions. Unit _height, duct _height. Avoid spaces in parameter names. Use underscores instead. Step 4. Test. Now we test the skeleton. Open the ref level plan. On the Create tab, click Family Types. For each parameter, enter a different value and click Apply. Watch the reference planes carefully. They should move. They should maintain their relationships. Nothing should distort or break. Test one parameter at a time to make errors easier to spot. Remember, you cannot test too much. Step 5. Add a 2D line work. Next, we add the 2D symbolic representation. Ensure the reference level plan is active. Go to the Annotate tab, followed by Detail panel, followed by Symbolic line. Choose Rectangle and trace over the main reference plane rectangle. Add a diagonal line across the rectangle. Lock all padlocks that appear. This ties the symbolic lines to the reference planes. Select one of the symbolic lines. Use Tab if needed to avoid selecting the reference plane. Click Visibility Settings, review the options. Symbolic lines appear only in views parallel to their creation view. We'll keep the default settings. Click OK. Step 6. Test again. Open Family Types once more. Change parameter values again and click Apply. Confirm that the symbolic lines move correctly with the reference planes. This step is crucial, especially when curves or complex shapes are involved. Step 7. Create 3D geometry. Now we begin the 3D modeling. First, hide the 2D line work so we don't accidentally lock geometry to symbolic lines. In the reference level view, select all 2D lines. Use Filter to ensure only lines are selected. On the view control bar, click the sunglasses icon, choose hide element. Now go to the Create tab, followed by Forms panel, followed by Extrusion. Choose Rectangle and trace the outline of the FCU body again. Lock the edges to the reference planes, click Finish Sketch to create the extrusion. We'll adjust the extrusion depth later. Step 8, test again. Open family types and flex the parameters again. Ensure the 3D extrusion moves correctly with the reference planes. If anything breaks, undo and correct the constraints. Step 9. Subcategorize if needed. For more complex families, you may assign geometry to subcategories for visibility control. In this simple example, subcategories are optional, but the principle is important for future work. Step 10. Add metadata and types. Finally, open family types and create one or more types. Each type is a saved set of parameter values. You can also add non-graphical data such as performance data, classification codes. This completes the family. And that completes the full exercise for Module 19. You've now created a fully parametric family using the 10-stage workflow. We've reached the final module, a moment to reflect on what we've accomplished and look ahead to what's next. Upon completion of the full course, you'll master the Revit interface and modeling tools, building confidence in navigating the environment and creating intelligent geometry. You'll be able to develop mechanical, electrical, and plumbing systems, integrating real-world engineering logic into your models. You'll be able to create schedules, legends, and annotated sheets, transforming raw data into clear, professional documentation. You'll be able to understand collaboration and BIM strategies, learn how to manage large projects, coordinate across teams, and maintain model integrity. You'll gain skills in family creation and editing, enabling you to build custom components that respond to design needs and project standards. And now, the next step is yours. Apply these skills in real-world projects, contribute to multidisciplinary teams, or pursue certification to formalize your expertise. This course will equip you with the tools, mindset, and methodology to thrive in a BIM-driven environment. Keep building, keep refining, and keep pushing the boundaries of what you can model.